Hi, sixth graders. Today we are going to talk about two things in our lesson. The first is box and whisker plots, which is a way to show data on a number line and see how spread out our numbers are. And the second thing we're going to do is talk about interquartile range, which tells us how spread out the middle sections of data are. Today we're going to talk about box and whisker plots. It's a way to show how spread out our data is. So these are examples of how some box and whisker plots can look. They're also generally shown above a number line so that you can know the value of each piece of our box and whisker plot. And you'll notice that some box and whisker plots have the pieces really close together. We've got the box, and then we've got the whiskers off to the side showing us how high and how low our numbers reach in our data. So you can see on this box and whisker plot, this is telling us that all of this data is pretty close together. Next, we have box and whisker plots that are more spread out. And then we have some box and whisker plots that have sort of some differences on different parts of our data. So if I notice the first three sections, we've got a whisker, one side of the box, the other side of the box are pretty close together. And then I've got this really spread out whisker, which tells me that there might be something like an outlier out here, a piece of data that's much higher than the others. We're also going to learn today about interquartile range. You might also see it represented with the letters IQR for short. And interquartile range tells us the variability or the difference between the middle sections of data. So what you do is you will take the third quartile, which we'll learn about, and you'll subtract the first quartile, and then that will tell you how spread out the middle sections of data are. So these middle sections right here that make up our box, we want to know how spread out are the numbers in those. Our data today is a survey that we gave to a bunch of different students of different ages, and we asked them how many hours they spent on homework during a week. And so some of these students were younger, some were older, some take a longer time to do their work, and some get things done quickly. So here are all of their answers in hours. You'll notice we have some lower numbers like 2 hours or 3 hours in a week. We have some higher numbers like an 11 hours or 14 hours in a week. The first step that we're going to do to represent this data as in a box and whisker plot is that we have to order our data. We know that if we're going to plot something on a number line, the numbers have to be in order. So the first thing we're going to do is we're going to rearrange all of these data points from smallest to biggest. So here are my numbers least to greatest. The first thing I need to do before I make my box and whisker plot is to find the median or the middle piece of data. So I'm going to eliminate the lowest and the highest until I get to the middle. So here I have my median. My middle number is an 8. So I'm just going to put an M here to show that I found the median. Next, I need to find what we call the first quartile, and it'll make sense in a moment why it's called that. But we need to find the median of the lower set of the data. So this median, this 8, this was used, so I circled it. It's no longer in the running. So let's find the median of this lower data. Let's find the middle number over here. Here we go. We have this 3, and I'm going to label this as Q1 for quartile 1 or first quartile. Next, I'm going to find the third quartile, and that will be the median number on the upper set of my data. So I'm labeling that Q3 or third quartile. And last but not least, I like to circle the highest and the lowest because these are going to become my whiskers. I saved this for last just because I need to know that my whisker is going to reach all the way up to the highest piece of data, which is a 14, and there's going to be a whisker over here that reaches to the lowest part of my data, which is a 2. The reason these are called quartiles is because, as you can see, by finding the middle and then the middle of the lower side and the middle of the upper side, we've created quarters. You'll notice that the data is now broken up into 4 equal sized groups. We have first quartile here, second quartile here that goes to the median. You'll also see that sometimes called the second quartile. Here's our third quartile, so that's why we're calling it quartile 3. And my fourth quartile is this last piece over here. So quartiles are breaking our data up into 4 equally sized groups. And the way that all of these pieces turn into a box and whisker plot is that we use these numbers that we've discovered to form either a whisker or a line in the box. So here's my recommendation. Just mark my 5 numbers. So here we have a number line. This 2 was the minimum, it's the lowest. So above my number line, I like to just hover up a point here at 2. Next, we have quartile 1, which is the 3. So I'm going to hover another point above the 3. My median, or my second quartile, was over here at 8. So I'm going to hover a point above the 8. And then quartile 3 is at 10. And my last piece of information is my maximum, or my highest, and that was a data point at 14. So here are all the points that we found that were important. And what you're going to do is you're going to turn the 3 middle points into our box. So I'm going to take my median of 8 and I'm going to make a line segment. I'm going to take my quartile 3, which is 10, make it into a line segment, and 3 is also going to turn into a line. And all I need to do now is connect these lines to form the box in my box and whisker plot. Next, we have the whiskers, and the whisker is showing us how far away the minimum and the maximum are. So we have the minimum over here. This whisker reaches to a 2, and this whisker on the right side reaches all the way to a 14. So a lot of you might be wondering, why is this box and whisker plot helpful? Well, it tells us a few things. Number one, it tells us how spread out our whole data is. So we could use a box and whisker plot to find the range of data. If my highest number is a 14 minus my lowest number of 2, I can tell you that the range of hours spent doing homework is 14 minus 2, which is 12 hours. There's a 12-hour difference between the times that it takes all these different students to do their homework. The next thing that it does is it shows us how spread out each part of this data is. So remember how we made these quartiles? And up here in my list, they looked exactly the same size. But what we notice on the box and whisker plot is there's certain groups of numbers that are really close together and certain groups that are pretty far apart. Our first group of numbers fit all the way here between 2 and 3. So this first quartile, 2s and 3s, those are super close together. Then we notice that my next quartile is really spread out. It goes all the way from 3 hours all the way up to 8. The numbers in this second quartile are much more spread out. And then we have our third quartile between 8 and 10, 8, 9, and 10. Those are pretty close together, and you'll notice on our box and whisker plot, those pieces are close. And then my last quartile, my last set of data, goes from a 10 all the way to a 14, so that's a pretty spread out piece of data as well. So this box and whisker plot tells me that there's pretty big ranges between 3 and 8. There's another big range between 10 and 14. Last but not least, the other piece that you might need to do with data is find the interquartile range. The reason we want to know interquartile range is because it tells us how spread out the center parts of our data. So these 2 quartiles near the center, how spread out are they? So I'm going to take quartile 3, which is 10, whether you're looking at your list or the right side of your box. We have a 10. I'm going to jot it off to the side over here. And then we're going to subtract, because we're finding the interquartile range, the range between my quartiles. I'm going to subtract quartile 1, which is 3. If you like box and whisker, you can also look here and see that this side of the box is at 3. 10 minus 3 is 7. So the answer to this question, what is the interquartile range? It would be a difference of 7 hours between my data points. So here are some notes that quickly recap the lesson from today. So feel free to pause this, screenshot it if you'd like, or just download them from the link that I've shared with you. So here's how we created our box and whisker plot. You can see that we took the hours spent on homework and we put them in order from least to greatest. We found the median in the middle. We found first quartile, third quartile, and then we also noted our minimum and our maximum numbers. We use them to create the box and whisker plot. And what I like about this picture is that they're color-coded for each part, so you can see how each piece of my box and whisker matches up to the data in my list. We have a reminder below that box and whisker plots are made to show how spread out numbers in a data set are. So remember how we said if it was squished in a box and whisker plot or really close together, that means that the data was really close. If they were longer pieces in our box and whisker plot, it meant the data in that section were spread out. These are all of our steps of how to make a box and whisker plot. Like I said, if you like this list format, feel free to screenshot these instructions, but it's got steps 1 through 8. This is what we did together. Number 1 is put things least to greatest. Number 2, find the median. Number 3, find the median of the lower half of the data. This is the first quartile. Number 4, find the median of the upper half, which is called third quartile. Number 5, find that minimum and that maximum value. Number 6, you need to use a number line. Number 7, you use the 3 quartiles, or those 3 median numbers, to create the box. And then the minimum and the maximum in step 8 are used to create our whiskers. It's also got a quick reminder at the bottom of interquartile range. Interquartile range is also called IQR, and it's the difference between the quartiles, the difference between the first and the third. So all you need to do is subtract the first quartile from the third, and you will get the range of those center groups of data. Because today's concept was new, you might want to rewind this video and watch things again, pause it, maybe take some notes. Feel free to make whatever decisions you need to be successful on today's assignment. Good luck, do your best, and reach out to me if you have questions.